Okay, welcome back. Chapter 21, Quiz A, questions 4 and 5. Again, I'd just like to take a minute and read the prompt. A company manufacturing computer chips finds that 8% of all chips manufactured are defective. Management is concerned that employee inattention is partially responsible for the high defect rate. In an effort to decrease the percentage of defective chips, management decides to offer incentives to employees who have lower defect rates on their shifts. The incentive program is instituted for 1 month. If successful, the company will continue with the incentive program. Question 4. Based on the data they collected during the trial period, management found that a 95% confidence interval for the percentage of defective chips was between 5 and 7%. Excuse me. What conclusion should management reach about the new incentive program? Explain. Well, clearly our confidence interval of between 5 and 7% is below the hypothesized value of 8%. So the data provides convincing evidence that the incentive program lowers the defect rate of computer chips. Okay, so the confidence interval contains values that are all below the hypothesized value of 8%. So the data provides convincing evidence that the incentive program lowers the defect rate of the computer chips. Okay, question 5. What level of significance did management use? So before I introduce this quick formula, I'd like to take a look at our normal curve. For 95% confidence, we know we have a z-score of negative 1.96 and positive 1.96. Okay, it's bound by those two z-scores, 95% confidence. We know this is true. We also know that our p-naught was equal to 0.08, or 0.08, 8%. And our alternative hypotheses would be P was less than 8%. So this tells me I have a one-tail, lower-tail hypotheses test. Well, what would the significance level be? Well, our alpha level or significance level is this shaded area right here. Well, if this is 95% of the normal curve, that leaves 5% left over. But that 5% would be split between each tail, okay? So if we're looking for a one-tail, lower-tail hypotheses test at a 95% confidence level, then we've actually used, there would be 2.5% here and then 2.5% here. So the level of significance of this test would be 2.5%. So the math that's involved here would be the alpha level, that's another way of saying level of significance, is 100 minus the confidence level divided by 2. This is the formula when we have a one-tailed test, okay? And for our sample, again, our alpha level or significance level would be 1 minus 0.95 divided by 2, or 0.025 or 2.5%, which I think in this case the picture was clearer to see. Okay, so the level of significance for this test was 2.5%.